we'll start off simply talking about what most everyone believes and understands, which is that a calorie is a form of heat energy that's given off during the processing of some food bit or something. If that's mysterious to people, just understand that a calorie is a unit of energy. And I was taught, and still many, many people worldwide believe, that a calorie is a calorie, meaning if I consume more calories in whatever form than I metabolize by thinking, feeling, moving, exercising, etc., then I will gain weight. And if I consume fewer calories than I burn, I will lose weight. And we could talk a lot about where that weight loss comes from. Does it come from adipose body fat stores, or from muscle, or from protein, or muscle, of course, is protein, etc. But let's start off with, is a calorie truly a calorie when it comes to the processing of different types of calories?
Now, it is true that a calorie is that unit of energy that raises 1 gram of water 1 degree centigrade. And so therefore, a calorie burned is a calorie burned. I don't argue that. That's true. That's, the first law of thermodynamics. But that doesn't mean a calorie eaten is a calorie eaten. That's not the same. And that's where people get it wrong. So let me give you some examples of how that calorie eaten is not a calorie eaten. You like almonds?
I do.
Me too. Almonds are great. Okay? You eat 160 calories in almonds. How many of those do you absorb? 130. You eat 160, you absorb 130. Where'd the other 30 go?
In the processing of that food energy?
No. Turned out the fiber in those almonds, both soluble and insoluble fiber, and by the way, fiber is sort of the key to the kingdom in this story, forms a gel on the inside of your intestine. The insoluble fiber, the cellulose, forms a fishnet, if you will, a lattice work on the inside of your duodenum. The soluble fiber, which are globular, plug the holes in that fishnet. Together, they form a secondary barrier. You can actually see it on electron microscopy, a whitish gel. And that prevents absorption of those 30 calories. So yes, 130 get absorbed, but many of them don't. They end up going further down the intestine to the next part, called the jejunum, and that's where the microbiome is. Now, everyone knows about the microbiome nowadays. It's all the bacteria. We always say when women are pregnant, you're eating for 2. Well, we're always eating for 100 trillion. Now, they have to eat. Well, what do they eat? They eat what you eat. The question is, how much did you get versus how much did they get? Well, if you ate almonds, they're getting those 30 calories. So even though you count the calories at your lips, that doesn't matter. What really matters is counting the calories at your intestinal brush border. Okay, and they're not the same. So if you feed your gut, that's a good thing, because then your gut will take those calories and turn it into things like short-chain fatty acids, which end up being protective against chronic metabolic disease. Acetate, propionate, butyrate, valerate. Those are actually good. They're anti-inflammatory, anti-Alzheimer's, because you fed your microbiome. So even though you ate 160, you absorbed 130. So a calorie eaten is not a calorie eaten, because if you ate it with fiber, it wasn't for you. It was for your bacteria. But that's not the way you count them up. So that's problem number 1. Problem number 2, amino acids. So we all eat protein. Let's say you eat too much protein. You had, the porterhouse steak. All right? Now, if you're a bodybuilder, those amino acids might go to muscle, and you might increase your muscle mass because you're a bodybuilder, because you're putting excess force on those muscles and you're growing those muscles. Okay, but let's say you're not a bodybuilder. Let's say you're a mere mortal like me.
Or let's say you're a kid going through puberty who's synthesizing a lot of muscle, not because they're lifting weights, because
testosterone's making it happen. Right. Yeah, absolutely. But let's say you're not. Let's say, you're just slump off the street like, Joe Schmo. Okay? And you eat that porterhouse. You've taken on all these amino acids. There's no place to store it other than muscle. So your liver takes the excess and deamidates that amino acid, takes the amino group off to turn it from an amino acid into an organic acid. And then that organic acid can then enter the Krebs cycle, the tricarboxylic acid cycle, what goes on in the mitochondria in order to generate ATP, the chemical energy that your body needs in order to power itself. Okay, now that's a good thing. It takes double the amount of energy to prepare that amino acid for burning as it does to prepare a carbohydrate for burning.
Or fat. Because when you asked about almonds, why the 160 versus 130, I thought it was the processing. It turned out it was fiber. You're saying for protein, let's make it realistic for a really nice big porterhouse steak, which I love, by the way. Let's say, let's make it actually realistic. A 1,600 calorie porterhouse with a nice slab of
butter,
of grass-fed butter on there. I'll do this every once in a while, not often.
With some cream spinach and maybe some mushrooms along the side.
Honestly, I say when I'm eating a porterhouse, I don't want to adulterate the taste with anything else except maybe some butter, maybe a salad afterwards. But let's say 1,600 calories of it's got some fat in there for sure. Let's say 1,000 of those calories is protein. The other 600 are fat. Something like that, depending on how marbled it is. Okay, so based on what you just said about the thermic effect of food and protein in particular, of that 1,000 calories, how much actually can we count? I'm not a calorie counter, but does one include as calories truly ingested?
Well, if you ingested 1,600,
well, that's what went in the mouth. But what is going to go against your burn deficit?
Right. So I would have to actually do the math to figure that out. But as a guess,
back of the
envelope calculation, you're going to lose about 25% of that.
Wow. So we're talking 750 calories.
Yeah.
And to translate this a bit, so what we're saying here is if you're somebody who is trying to lose weight or maintain weight or perhaps even gain weight, you eat a 1,600 calorie porterhouse with a slab of butter on it. 600 of those calories we're saying in this instance is fat. Of the remaining 1,000 calories, that all went in your mouth.
So you counted at your mouth.
Right. But 700, but then when you compare it against your energy burn for that day to maintain temperature, brain activity, physical activity, really it's only 750 calories.
That's right.
That's a huge difference.
Exactly. And another reason why a calorie is not a calorie. Now let's take the third. Let's take fats. So over here we have omega-3s. Heart healthy, anti-inflammatory, anti-Alzheimer's, save your life. And over here we have trans fats, the devil incarnate, consumable poison, because you can't break the trans double bond. You don't have the desaturase to break that trans double bond. So it basically accumulates, lines your arteries, lines your liver, causes chronic metabolic disease, causes insulin resistance. Omega-3s don't even get broken down for energy because they're so important. They stay intact because your brain needs them, your heart needs them, whereas trans fats can't be broken down because of that trans double bond. One, save your life. Other one, kill you. They're both 9 calories per gram if you explode them in a bomb calorimeter, because a calorie burned is a calorie burned, but a calorie eaten is not a calorie eaten because one will save your life, one will kill you. And finally, the big kahuna, the one that blows everything else out of the water, fructose and glucose.